Okay, so in this we're going to cover radicals, how to group them, what they are, and how to work with them. Okay, so a radical. So this is, what is it? I mean, the radical is kind of just this. So radical, and if that's A, and then we have A, we'd say that's the radicand. So the radical is kind of just the root, and then what's underneath it is called the radicand. Now there's like, and those are, let's say I had 3 root 3 and minus 2 root 3. I could group those because they have the same radical. So they're like radicals. So I could say 3 root 3 minus 2 root 3 equals root 3. Now I might have another case. Let's say I had 2, and I have the third root of x, and then I had minus x and the third root of x. These are also like radicals because I could just say, well, that's 2 third root minus x of the third root of x. And that is just, I didn't leave enough room here, but that equals 2 minus x third root of x. So I had to factor this out, and I'm left with this. Now you have unlike radicals, with big U, unlike, and that's just something like the root of 7 and the root of 3. So these are unlike. I can't group them. So another way, another unlike radical would be something like, let's say you had the third root of x, and then you also had the third root of x squared. These are different. We cannot add or group them together. So there's one other thing that we should talk about, and that's that the square root of x, we can write that in our exponent as 1/2. And if someone had written the third root of x, that's x to the 1/3. So that's how this works for exponents. Now, here's something else. Can we have a negative under the radical? So can 4 minus x be less than 0? And the answer is no. And that's because the radical is saying, what is the root of this? So let's say we had the square root of 4. Well, I know that is going to equal 2, or it's going to be negative 2. But what two things multiply to negative 4? Can 2? 2 times 2 won't equal negative, and negative 2 times negative 2 won't be a negative. So there's nothing here. There's no solution. No real solution is what we'd say. Because in advanced math, there is imaginary solutions. So how would we solve this? Well, what we now know is that if we have this, then we know that 4 minus x has to be bigger than or equal to 0. And if we add an x to both sides, that shows us that 4 has to be bigger than or equal to x. So that's a pretty useful thing, and you'll need to know how to do that. Now, there's another case. What if we had something like, let's do it right here. I'll do it in one big long line. We had x minus 4. Now, it looks the same as this, but it actually has a different outcome. Now it's x minus 4 has to be bigger than or equal to 0, which we add 4 to both sides. And what we get is x must be bigger than or equal to 4. So this shows us that x has to be big and positive, whereas over here, this one shows us that x has to be small or negative. So they're two different solutions doing the same thing. So though it may look the same, you can't actually, you have to solve them separately. They won't have the same solutions.